Discuss about evidences for the E2 mechanism. So the first evidence is isotope effect. So the second order elimination shows a large hydrogen isotope effect. So before going to isotope effect, what is meant by an isotope? So isotope means they have the same atomic number but different in mass number. So what are the different isotopes of hydrogen? Protium, deuterium and tritium. So these are the different isotopes of hydrogen. So hydrogen is having the atomic number 1 and mass number is different. So different isotopes of the same element have by definition the same electronic configuration and hence similar chemical properties. So this similarity is the basis of the isotopic tracer technique. So different isotopes have different masses, and because of this their chemical properties are not identical. The same reactions can occur but at somewhat different rates. So change in rate brought about by replacing an hydrogen atom by its isotope deuterium. A difference in rate due to a difference in the isotope present in the reaction system, and this is called as an isotope effect. So as we learn all these mechanisms of substitution and elimination, you should appreciate how we have come to know how the mechanisms occur. So one way we to study a mechanism is to see how replacing a hydrogen atom with its isotope deuterium affect the rate of a reaction. So if the rate is affected, it is likely that particular hydrogen atom is involved in the rate determining step. Okay, so നമുക്ക് അറിയാം ഇവിടെ റേറ്റ് ഓഫ് ദി റിയാക്ഷനെ അഫക്റ്റ് ചെയ്യുന്നുണ്ട് എങ്കിൽ എപ്പോഴും ആ ഹൈഡ്രജൻ അതിൽ ഇൻവോൾവ് ആയിരിക്കണം അല്ലേ. സോ നമ്മൾ ആ ഹൈഡ്രജനെ മാറ്റി റീപ്ലേസ് ചെയ്ത് അവിടെ ഡ്യൂട്ടീരിയം കൊടുക്കുകയാണെന്നുണ്ടെങ്കിൽ അതിൻ്റെ റേറ്റ് ഓഫ് റിയാക്ഷനിൽ ചേഞ്ചസ് വരുമോ എന്നാണ് നമ്മൾ ചെക്ക് ചെയ്യുന്നത്. ഓക്കെ, സോ നമുക്കറിയാം ഹൈഡ്രജൻ്റെ ഐസോടോപ്സ് ഏതൊക്കെയാണ്? പ്രോട്ടിയം, deuterium and tritium. So deuterium, which is having a mass number 2, and hydrogen, which is having a mass number 1. So deuterium has the same chemical reactivity as hydrogen. So consider the following reaction where an alkyl halide undergoes elimination with a strong base, which you already know is called an E2 reaction. So look at this reaction. So here the base react with alkyl halide. We can get alkene plus protonated base plus Br minus is the leaving group. So when we replace the beta hydrogen with deuterium, the reaction occurs at a slower rate, and this is called the kinetic isotope effect. So here we can replace the hydrogen atom with deuterium. So we can get a alkene with deuterium plus a deuterium base plus Br minus. So here the CD bonds are stronger than the CH bonds. So if we are replacing the beta hydrogen with deuterium, result in a slower rate by more than a factor of 5. So then we can conclude the breaking of the CH bond occurs during the rate determining step. So the reaction above is nearly 7 times slower with beta deuteriums instead of beta hydrogen. So this is one of the reason why we know that E2 elimination is a concerted elimination. So usually the CD bond is stronger than a CH bond. So it is usually expressed as KH by KD. KH means the rate of the reaction while hydrogen is present or protium is present, and KD, the rate of the reaction when deuterium is present. So if KH by KD is equal to 7, so this means that the isotopically labeled bond is being broken in the rate determining step, indicating that the reaction is E2. So we assure that deuterium affect the rate of the reaction. So the particular hydrogen atom is involved in the rate determining step, and this is called as kinetic isotope effect. So the hydrogen isotope have the greatest proportional differences in mass with deuterium. It is twice as heavy as protium and tritium. So is 3 times as heavy. As a result, hydrogen isotope effects are the biggest, the easiest to measure. Isotope effect due to the breaking of a bond to the isotopic atom and is called the primary isotope effect. So a bond to protium that is broken faster than a bond to deuterium. So deuterium isotope effect as large as 5 to 8 have been observed. So that is to say the reaction is 5 to 8 times as fast for ordinary hydrogen as for deuterium.